So today we're going to be talking about how to illustrate how a mutation, like a point mutation or frame shift mutation, causes an addition or deletion of one base pair, and it will result in a truncated non-functional mutant protein. So before I even get into this, I didn't even know what truncated meant. It means shortened by cutting off the top or the end. And so then non-functional means complete or partial loss of function. And so I'm just going to go to the slide that we used in the book. And so here we can see a nonsense mutation is where one base pair replaces a base pair on the coding strand, and it comes out on the mutant strand as a different stop codon instead of being what it should be. So the next important thing is that we're given the 5-3 sequence of the normal and the mutant strands, and we've got all of the amino acids. So now we need to use our little amino acid chart to figure out what the codons are that match these amino acids. So now that we have all of the codons that match the amino acids, we need to look and figure out where there's a difference between the normal strand and the mutant strand. And so if you see methionine and tryptophan are the same, but then there's a difference between these two amino acids, and it's because there's an insertion here, because we can see that there's a U and a U, and then a U and a U. So this is where the insertion is. So now that we know that the insertion occurred here, we can see that there's a U and a U on this mutant strand. Now we need to find where it pairs up here. So there's a U and a U here. So then the next possibilities that we have are a C and a U, and because this mutant strand uses this C, then we know that it can't be this U, it's going to be this CAC. So then we know it's going to be CAC. Finally, all stop codons start with a U. So we know that we're going to have to start with this U right here. So it's going to be U then AA, which we have right here. So UAA. By using the codon sequences, we were able to find out the amino acid by finding where the base pair insertion was. And so now we have the complete coding sequence, including the stop codon of the mRNA that is translated into the mutant protein.